Secondly, what we are doing, we have to draw a polygon very similar to the polygon drawn for the multiple masses on a single plane. So for the couple polygon, what we will do, we take a suitable scale and we equate the scale to the magnitude. For example, there will be some magnitude of couple C1, so we will equate this to the scale. For example, couple will have some magnitude 100, then we say that 10 is equal to 1 centimeter. So by this we will draw a arrow, and the magnitude of arrow represents the magnitude of couple C1. As you can see, the couple C1 is on horizontal, so there is no angle theta. The angle theta 1 is for the couple produced by mass m2 or fm2, and the angle is theta 1, and the magnitude of couple 2 is represented by arrow start from here, ends at there. The third couple is C3. In case of C3, the magnitude of couple C3 is represented by this arrow. Start from here, ends at there, and the angle theta is theta 2 from the horizontal. So to close the polygon, we will draw an arrow which will meet tail to the first arrow and end of the last arrow, and the magnitude of this final arrow which is closing this polygon represents the magnitude CB2. So by this means we will know the magnitude of couple CB2. If magnitude of CB2 is known, then we can find the mass B2. RB2 is already known. L3 is known. The only unknown is mass, the balancing mass B2. If all the others are known, so what we'll do, by CB2 is known by this polygon method. We divide the magnitude CB2 by RB2 into L3. So what we'll get? B2 is now known. Next, we will draw a force polygon. In case of force polygon, the additional force is from the mass, the balancing mass B2, which is FB2, because if the balancing mass B2 is known, the radial distance RB2 is known, then we can easily calculate FB2. So FB2 is known in our situation because we already have calculated mass B2. From this mass B2, FB2 can be easily calculated. So in case of force polygon, we will draw in a scale. We will draw the scale, and by this scale, for example, this arrow represents the magnitude of Fm1, then this arrow represents the magnitude of Fm2 at certain angle theta 1, then the arrow here represents the magnitude of force Fm3 at the angle theta 2. Start from here till end here, start from the horizontal, end it here. Then comes the balancing force FB2 represented by the blue arrow, so it's at angle theta B2. To close the polygon, we have to draw an arrow which will meet the tail of the final arrow will meet with the tail of the first arrow, and head of this arrow which is closing this polygon will meet the head of final arrow. So we will measure this distance from tail to head. It will be the magnitude of FB1. So if FB1 is known, RB1 is already known, the distance, the radial distance of balancing mass B1 from this axis of rotation. Then we can easily calculate the unknown mass, the balancing mass B1. Just divide FB1 by RB1. So by this way we can easily calculate the unknown unbalanced mass B1.